right, for the final panel on the big stage, Taking Flight. The future is here, and they will bring together leading experts to discuss the integration of emerging technologies into the NAS. Please welcome panel moderator, Vice President for Center of Integrated Transportation for MITRE, Kerry Buckley.
Thank you, Don. Good morning. Very excited to be here. It's great to kick things off and really set us up for the future with this last panel. This session is also going to be an opportunity for all of you to put into practice some of the things that we learned from Dr. Amy Grubbs on the first day about being curious, as well as really bringing to life what the call of this entire conference is in terms of navigating the future together. We will be using the Slido tool. We'll be open for some questions, so please make sure that you enter those in, and we'll get to as many as we can. I'm going to build a little bit on the discussion that happened here on this stage last year. That panel was called Meeting the Demands of Tomorrow, where we discussed the new entrants and the operations of drones entering into the system, small UAS, eVTOLs. The session today, as Don mentioned, is called Taking Flight, The Future is Here. So one could say that last year's tomorrow is today. So I'm going to start very briefly reflecting on last year's discussion. The panelists emphasized the importance of working together in parallel with industry, NATCA, GA, traditional aviation, and airline partners, as well as facilities. And the importance of collectively working together to learn about the tools, information, procedures, and policies and infrastructure that will be needed as advanced air mobility operations grow, and we work to provide access to the same airspace for all users. The panel also acknowledged that there's been a lot of talking, we've been reading a lot of reports, a lot of CONOPs have been written, but also acknowledges that we are getting to the point where we really need to get into operational testing, and that going from CONOPs to ops is not trivial. We also heard a guarantee from NATCA last year. Every controller in the room was guaranteed that your job, what you do day in and day out, will not be the same in 5 years. You'll still be maintaining safety and maintaining the efficiency of the airspace, but as we put more stuff, and that's a quote, in the airspace, you are going to be more important and more impactful than ever. And the final takeaway from last year's conversation was the recognition that this is going to be an evolution. It's going to be continuous learning. We won't walk in someday and flip a switch and turn off the old NAS and turn on the new NAS. So this panel is part of that evolution and that collective learning together. We will be focusing on near-term integration of AAM and eVTOLs to include preparing the airspace and the infrastructure to accommodate AAM operations, challenges and opportunities we anticipate and are already seeing, and how pilots and controllers can not just prepare for these near-term operations, but also participate and help design the future together. So to start the conversation, it's my pleasure to introduce Christabelle Bosson. She's an engineer, an airspace engineer at Joby. Christabelle's work focuses on supporting the development of airspace access plans, as well as building airspace analysis tools and air taxi simulation capabilities to support the seamless and safe integration of Joby urban air operations into the airspace. So Christabelle, please join me. Come on. Wonderful, welcome. And we have the treat of having a Joby video playing here in the background as Christabelle explains some of the work that she does along with Joby. So if you could first just kick things off and tell us about Joby's mission and vision.
Sounds great. Thank you. Hi, everybody. So I'm Christabelle. So let's talk about Joby and who we are. So we are a California-based company, and we've been focusing on building electric propulsion and aviation for more than 10 years. At Joby, we're developing and manufacturing a fully electric vertical takeoff and landing aircraft. This aircraft is piloted. It can carry up to 4 passengers. It has a range of 100 miles, no in-flight emissions, about 200 miles per hour for the top speed. This gives us the flexibility of serving any community. Now, getting into one aircraft feels more like getting into an electric SUV rather than boarding a plane. Okay, now let's compare it to today's VTOLs of the sky, the helicopters, the V-22s, where we are extremely quiet. I hope you had a chance to check out our sound experience at the booth. I know it's no longer there, but if you haven't, maybe at the next conference. When did we start flying? The first full prototype started to fly in 2017, and since then, we've accumulated over 33,000 miles. It's more than around the globe once. Joby intends to both manufacture and operate the aircraft, and we're targeting commercial operations launch in Dubai at the end of 2025. Now in the US, back in 2018, we've formally applied for type certification, and we are currently in the step number 4 out of 5, and these days we've been completing full credit testing across all systems of the aircraft. Now we are also working with regulators around the world, like in Japan, in the UK, in Australia, so that we can test and validate our FAA type certificate in these markets. But we're also working with regulators in the UAE and Dubai to prep for launch. But once we have our type certificate, we'll focus on the US markets. All right, so how many people work at Joby? About 1,800. And we are scattered around the US, on the West Coast in California, on the East Coast, New York and Washington, DC, but as well in Europe, in Germany. And lately, in California, what have we been up to? We've been ramping up manufacturing in our pilot plant production line in Marina, California. And 3 of the production prototype aircraft rolled off the line. One of the aircraft was delivered at the Edwards Air Force Base for joint flight testing activities with the Air Force, and another one will join it very soon. Now, coincidentally, about a year ago, CFS last year, we've announced our first full production line will be built in Dayton, Ohio. Now, it's not for now. If you compare the scale of these manufacturing operations in our current plant in Marina, about tens of these roll out the line per year. With the full production line, it will be more on the hundreds in terms of comparison. Now, Joby has partnered with Delta Airlines, but also with Toyota and Uber, to bring to market a service that changes the way people move around cities, but also helps to get around those congested cities, especially like to and from airports. So at Joby, we're excited. We're really focused to bring this electric service to market. And there's 2 things that I would like to add. Back in 2022, we received our 135, or Part 135 air carrier certificate, which allows Joby to operate a commercial air taxi service. And we have, since then, gained a lot of operational learning with our fixed-based operations. Another piece of information. Back in November, we had the great privilege to participate to an event in New York that was organized by Mayor Eric Adams and the New York Economic Development Corporation. You may have seen footage of that flight right here, actually. It's not virtual, it was real. Actually, it was our first flight outside of California, and we're so happy it was in New York. We were able to demonstrate our technology to the communities and the stakeholders, and they were able to witness how quiet the aircraft is. We're also really happy to see that the city has made great progress on key infrastructure to bring electrification of the downtown Manhattan helipads. So that was a lot of information, but to recap, our vision is to really support the way people move around cities and to bring the people where they want to go.
That's great. Thank you, Christabelle. That's an incredible amount of progress in a short period of time. With all of that, what would you say are some of your biggest challenges right now?
So Joby's intention is really to integrate the airspace in a seamless way so that it is compatible with the way the airspace works today. On one hand, we've partnered with Uber to deliver this transformative multimodal transportation that combines ride-sharing, you all are very familiar with it, with the power of zero-emission flight. We've also partnered with Delta Airlines to deliver this seamless emission-free travel to the Delta passengers that are going in and out of airports. So from an operations standpoint, how the operation will look like, you pull up your app, you put your origin and destination, and then you submit your trip request. We'll take care of the rest. We'll offer you options. You'll pick one, you'll pay, and then voila, you're on your way to your next Joby trip. Now, from an operation standpoint, we are an electric VTOL. And beside the electric, we are, just like any VTOL today, we take off and land vertically, but we fly forward on the wing. So we just think that it's going to look like VFR operations, just like helicopters fly today in the airspace. Now, if we talk about some of the challenges, it's not so much about finding infrastructure. There's actually a lot out there. So we can reuse, and we will reuse as much as we can. What's a bit more challenges is activating those sites to make sure that they are compatible with the infrastructure that we need, like electrification, to make sure that we have charging systems to support our operations.
So I'm really excited to pull up my app and order my first Joby ride. Can you describe a little bit what the initial launch sites might be? Where can we go and do this first? And then finally, a little bit more on that integration component, because I know that's something that folks are really interested in.
Great. So like I said at the beginning, we're targeting commercial launch by the end of 2025 in Dubai. We're working with regulators around the world. And we're working on our type certification, meaning that with the FAA, once means we have it, we'll focus on the US market. In terms of the airspace integration vision, I really want to point out that our North Star is to establish operations that are compatible with the way the airspace works today. We are not going to disrupt the existing air traffic flow. We are a 4-passenger aircraft. That makes absolutely no sense for us to go and disrupt an A350 operated by our friends at Delta on final. Instead, we actually want to help Delta and bring the passengers to those aircraft and bring them back home when they're done with their travel. So at Joby, we believe that one of the main considerations is the coordination with air traffic control, all of you here in the room. And we want to work with you and all the facilities to establish operations that are compatible with the way the airspace works, but also find locations that are compatible with current operations. Now, it's great. We want to bring the people where they want to go, but at the same time, that means that we may get close to airports. Again, we want to work with you to make sure that these operations are streamlined and well-known, and we want to work with you to ensure that they are safely integrated in the most compatible ways.
Thank you. Wonderful oversight. I think now we're going to invite the rest of the panel members to join us. So you and I are going to shift down just a bit. And first, I'd like to welcome Will Hutson. So Will is NATCA's National UAM representative. So if you'll join us. Great. Next, we have Rob Goldman, Senior Manager, ATM and Captain at Delta Airlines.
Oh, boy.
Here you go. You got some fans.
I got some fans.
Next is John Maffei, FAA's Deputy Director of Portfolio Management and Technology Development. And finally, I want to thank our next panel member for flying in this morning to join us. We've got PK, NASA's Mission Integration Manager for the Advanced Air Mobility Mission. So welcome. All right, so let's get started. We just heard about Joby's near-term plans and operations. We have other air taxi providers like Archer and Beta. We also have some large autonomous eVTOLs and HVTOLs on the cargo side. So from OEMs such as Elroy Air, Mighty Fly, Reliable Robotics, and X-Wing. So these have now been approved for testing and demonstrations on assigned corridors or on military bases, as we just learned. And of course, there are other manufacturers who are looking for certification overseas. So as these AAM OEMs are looking to initiate operations in the next few years as piloted VFR operations, what considerations are needed to prepare the airspace and the infrastructure to support initial operations? And John, we'll start with you.
Yeah, so about 2 years ago, we kicked off within the agency the effort to how we're going to safely integrate AM. The manufacturers such as Joby and others were working their way through the certification process. They had timelines that these vehicles were going to come out and be ready to enter the operation. And we realized that we needed to start working on how we could safely integrate those going forward. In order to do that, to answer that question on how are we going to do that, we really had to understand that how are they going to be equipped? What does that service look like that we're going to provide them going forward? So we had to do a whole effort of reaching out to industry, meeting with the industry partners, the Jobys, the Archers, all the manufacturers to understand what are the aircraft coming off the line, how are they going to be equipped, what are they going to be like, what are their vision of how they're going to operate, how do their partners, the airlines, such as Delta and others, how do they see them operating? And then go to the major airports, like LA, the Dallases, the New Yorks, and go, hey, are you ready for this? Where do you see this AM thing fitting into your world? And when are you going to be ready to do it? When we're able to get all those people together and get to it, we're able to really nail down what does that first operation look like conceptually, which is, as you said, right, it's a VFR operation, it's piloted, it's equipped for the airspace it's operating, and i.e. they're going to have VHF radios, ADSB out if they're in ruled airspace, right? And we're going to have to leverage existing infrastructure and equipment because the timing for when they're coming in and they want to operate, we don't really have the time to make big automation changes or anything like that. So how can we execute this within the constraints of our current automation and these things? So in order to do that, we had to work with industry, coalesce around this is what it looks like, and then find some areas where the industry partners and those airport authorities have coalesced and we're all ready to move forward to do this so that the FAA could start doing modeling and simulation with the industry partners to move that forward. So we started out with simple things like just doing quick time modeling at the tech center. We moved on to doing tabletops. We've done tabletops with LA already, which involved NATCA controllers from the facilities when they came to do that. And here in a couple of weeks, we'll be doing our first simulation at the tech center. We'll be working with our partners to do some simulations at the tech center, landing at multiple locations at the airport that are kind of locations that the airport, LAX, thought might work. The controllers thought were feasible, and we're going to run them through, walk them through, see how they go. And it worked for the operators from their business models and the things that they wanted to do. So that's kind of what our first look of what the operation is going to look like and where we're moving to, right? So it's working with the current environment that we have. We realize that this is going to be low density operations, and as it spools up and we said increase in operations, we're going to need to do a lot of stuff to get ready for that, right? And that's the longer term research that PK will address here as we go forward and work with our industry partners. So,
I think, John, you made a really important point is that scale up. You know, day one, the single VFR flight, you know, that's one thing. But as we integrate into the operations, you know, what does that look like in the congested airspace? How do you scale up? What does the modeling look like? And you know, I'm looking forward to seeing the results of that going forward.
Right. Like we said, this is going to be iterative, right? Like anything we do, that crawl, walk, run, right? This first simulation we're doing is going to be, you know, no off nominals, right? Perfect conditions. Let's go in. Let's see the interactions. Let's see the controls can do this. And of course, we'll have to iterate and throw some curveballs into the near surface, look at off nominals, other things, and see how that plays out and if it really works in these environments. Yeah. And find the break point. How much can we throw at the controllers in these operations, in these locations, and not upset the operation?
Indeed.
Will, anything from your perspective on?
Well, yeah, totally. So when you look at kind of new, exciting, novel things that come on, you get new, exciting, novel buzzwords. And one of those you'll hear a lot is key enablers. And I see so many times some people jump immediately to technology or you know, regulatory reform. And from my perspective, the key enablers are the aviation professionals, a lot of them sitting in this room today, our colleagues in the flight decks, our experienced engineers, our aircraft certification personnel. Because you can have the best tech in the world, but if you don't have the expertise to bring that on board, to integrate it, to evolve it as the system grows, it's going to sit on a shelf like we've seen so many times before. So when you look at that, when you look at the person, Andrew talked about it yesterday in his keynote about the off-nominal and the human being that key element to move, you know, technology and everything else forward. When we look at bringing AM on through that lens, from our perspective, the stuff that we need, one is early and often involvement, not just at the national level, but as John mentioned, we've created a collaborative process to look at this together collaboratively and build from it as we go from, you know, major airports down into what it would look like in the rural and the package delivery, medical supplies, all this type of stuff. But the key there is having the people that know how to bring this on board, develop it. We can have engineers, we can even have retired air traffic controllers, we can have all these people come together and think they have a solution, and then you bring the people that need to be in the room in there, and they're like, this is how you do it, and that's how we move forward. So that early and often engagement is great. We've had an incredible partnership with the FAA. They have backed us with every resource that we've needed to move this on. We've asked for extra dry runs. Whatever we've needed, we've been there because they see the value in having our expertise in the room when we're up there, and that's huge. The other thing that we're gonna need, as you've heard at a safety conference time and time again, is training, and not just check the box training, not just on ELM, robust training and evaluation of these potential use cases, and making sure we support the workforce to be ready for those day one operations, right? And last, again, be remiss, we've talked about it, you've heard about it all week, is staffing. And why is staffing important for AAM? Well, through some of this research that we've done with NASA, with Joby, we've looked at some scenarios where we can use either existing positions that either don't have the bodies or not, fully utilized today in some of our air traffic facilities, and really we've looked at the value of standing up some new standalone positions to work these new entrants. Again, it's kind of like the technology. We can, if we secure the resources and put the equipment in our towers and our facilities, but we don't have the people in there to plug in and work the airplanes, it's an issue. Early on, we're not going to see 1 million of these day one, but this is something that has been referred to as the next era past the jet age, right? The biggest change since the jet age. So if this is going to scale to that level, we have to be prepared.
Great. We're going to get to the research question in just a minute, but we also discussed just the availability of the FAA webinar series on this. So if folks really want to get access to that, I don't know if you want to share a little bit more, John, on that.
Yeah, so we've been running a series of webinars, basically quarterly, I think it's been about, that we've walked through different topics. The last topic that we just did a week ago was a webinar on our modeling and simulation capability that we have up at the Tech Center. That's where we're going to run our controllers through these simulations, and we'll talk a little bit more about that when we get to the research section here. But that is publicly available, and we can get the link. I don't know it off the top of my head, but we can get that and make that available and back out to the crew. Believe it or not, it's one of the most popular FAA websites. The visitors to that webinar series is the top hitting thing for the FAA right now. So there's lots of people in the outside world that go into that and looking at the different topics we've done on AAM. Since we started, basically, this fall will be 2 years that we've been working this integration effort cross-agency and with industry, right? And it's been very fruitful to date, that collaboration across all the different stakeholders.
Great, thank you. Christabelle, a little bit more on kind of the airspace and air traffic considerations so that we can make Joby's concept of operations real in terms of service entry.
All right, so Joby's intention is to really integrate the National Airspace System in a way that is compatible with the way the airspace works today. So we want to work with the FAA, and we've been involved in some of these recent modeling and simulation activity, and we've been providing detailed performance data about our aircraft so the FAA can model accurately our operations. And we're very grateful, so thank you again for involving us. And we really look forward to the results that will come out of those simulations. We are a powered lift aircraft, and so we know that in a few months, we'll expect some policies to be provided by the FAA. I won't talk much more about that, but this is coming, and we're also looking forward to getting any guidance in terms of airspace integration.
Good. Anyone else want to add on the concept of operations component?
Just from our perspective, Joby's been a great partner in this. They really believe in air traffic control. Christabelle will tell you she loves to just go and listen and watch, and she really has been an incredible partner, the entire airspace team there, and they realize that we're the solution to this problem. And so they've been incredibly open-minded as we kick back different ideas on how best to be ready for day one. And again, just appreciate the partnership with them.
So it was great to hear in your earlier comments and in discussion already all the collaborations that are happening. But Rob, from a traditional airline perspective in Delta, how have you been working with the team? What concerns might the airlines have? And then again, what opportunities do you see?
Well, first of all, thank you for inviting the, what did you call me, the traditional airline. We got to have a better term. You know, you got AAM, UAM, we got to find something better. Last time I checked, I think we have made up roughly 5% of the GDP, so we're still relevant. Indeed, I'm glad you also asked the question, balanced both opportunities and concerns. So, as mentioned, you know, Delta is an airline, but we're indeed a transportation company, and you know, we're in the business of transporting our customers and as well as cargo from point to point. We have something called a travel ribbon, and it starts well before the flight. It's how you book your flights and how you get to the airport and how then to your destination and back. So we are looking at all different modes of transportation that we can utilize as part of that travel ribbon. And as mentioned, you know, Joby is a partner, and we see a lot of opportunity in you know, bringing more people to the airports and then taking the Delta flights, being more efficient and more you know, environmentally friendly. So we see a lot of opportunity as part of our overall business model. Concerns, I think Will brought up you know, some of them before, and I indeed, you know, throughout this conference, you know, we've been addressing a lot of this. You know, we are resource limited, you know, financially, of course. The controllers, how are the controllers going to be able to, you know, train for this, speak to more operations, you know, all these questions that you know, are unanswered right now, but of course there's a lot of collaboration, both with NATCA, the FAA, you know, NASA, and I think we'll get into some of that. So we are concerned about how that will impact our operation. You know, we're all about efficiency and making sure that our customers get to destination on time, but we are very encouraged by the levels of collaboration and the groundwork that's leading in to this next part of our you know, our future together.
You know, the thing I'd add to that, in a lot of our conversations we've had with the industry stakeholders, the airport authorities, is that understanding that, hey, the Deltas, the Uniteds, they're going to partner with the Jobys, the Archers, they want to do this, it's the seamless part of it, but in the same sentence they'll say, but this is in addition to our operation. It's got to be synergetic, it's got to add to it. We're not looking to give up any throughput at airports, right? The airport authorities, the major airlines, it's like, you know, we're not giving away a heavy metal slot for this operation, right? It's got to fit in seamlessly to complement that and move our operations.
Yeah,
100 as we do that. Right?
100%.
So.
And you know, to Joby's credit, on day one, they said just that. They said, we are here. We're not going to impact your operation. You know, we are going to find a way to fit into it, and we get that. You know, I guess the sort of the tangential part of that is we're the resource limits, right? And that's where we don't know what we don't know. And again,
the model we have to learn as we go through, right? Is how do we pull that off? That
right. Airspace, I think we can figure out pretty quick. It's beyond that.
Okay, so let's jump into the research component of all of this from a NASA perspective. So PK, to you, what are some of the recent and ongoing research efforts that address some of the challenges that new operators in the NAS will face in integrating into the system?
Yeah, that's a great question, and let me give you a little bit of preamble as to why NASA is working on this. I personally think that advanced air mobility has a true transformative power of changing the society at large. If you look at the history of civilization, people lived near the banks of the river because one of the reasons was the access to transportation. Then came along the roads and surface transportation, and everybody goes to the central business district for work because that's where the road takes you. People live near the highways and roads because it's easy to get access to transportation. Now, if you fast forward 50 years from now, 100 years from now, advanced air mobility can actually change that dynamic completely. You're no longer confined by the road and rivers and seas. You can actually go through air anywhere you want. 1 mile of road takes you 1 mile, but 1 mile of aviation land can take you many, many miles. So that's the sort of the true transformative power of advanced air mobility. You can do 360-degree transportation anywhere you want. There will be much more integrated living with greener spaces, houses, office complexes and such. So I think that is very, very powerful, and that's very much inspiring us to kind of look into this advanced air mobility and how we can transform the society at large. So that's the basic idea, why we are doing this. However, in order to get there, we need to really figure out how will society accept this. And the society can accept this if there are benefits to everyone. It has to benefit to entire society. In order to get those benefits, safety is an issue, you all know about that. Noise is a concern about aviation. Affordability is a big problem it has to work for everyone, so it has to be affordable to everyone. In order to get that affordability, it has to scale. Scaling has two dimensions. One is manufacturing and supply chain, and other is airspace operations. It has to scale in a safe manner. And last one is equity. It has to benefit everybody at large. So let's break that down. So noise, so what are we doing in terms of noise? At NASA, we are basically building design tools to assess the noise characteristics of aircraft. We can study the aircraft. We have basically long-lasting research on figuring out what would be the noise footprint of certain propeller design and such. So we're working on that. We're helping industry with that. We are also going to build a trajectory model. Moving forward, it's no longer adequate to say demand capacity balance is based on just the volume, but you also have to consider the societal considerations of noise and emissions. In the case of electric aircraft, it's noise. We can do trajectory models that include noise as part of the parameter, not just the 4 dimensions, but the noise will be added to that. So that's another research that we are working on. Second is the safety. So we are working on design assurance, particularly autonomous aircraft. How do you assure that the design is going to lead to safe operations? We are working on technologies that should go into the aircraft themselves, like detect and avoid, hazard avoidance and perception, ability to operate with or without GPS. And then we are also doing some conventional safety things like drop tests and such. Third aspect is for societal acceptance is passenger basically experience. For that, we have simulators that allow us to do vibration, acoustic test inside cabin, outside cabin, and handling qualities of the aircraft. If you know Kopardekar, a handling quality scale that's been there for a long time by one of the NASA test pilots or a couple of test pilots. So Cooper, by the way, George Cooper, after he retired, he has a wonderful winery. He's passed away now, but he has a wonderful winery. If you're in the area in NASA, Maffei field area, you should go visit it. You will see also the test artifacts and such. It's a really fascinating experience there. But so we are working on handling qualities as another example of how do you make sure that the passenger experience is going to be really good and meaningful. Then for scalability, airspace integration, we talked about it here. How do you make sure that these operations will occur in a safe manner without overloading the conventional air traffic management, without disturbing them? So we have research that's going on in terms of the tools that are necessary for pilots, tools that are necessary for air traffic management and traffic management operators, traffic management unit and such. So how can we actually make sure that these operations can scale without overloading the conventional ATM system as we know? And last aspect is the supply chain and manufacturing. How do you make sure that we can scale these operations in terms of manufacturing? So if you look at current aircraft manufacturing capabilities, there are 800 aircraft, Boeing 800, Airbus. If you look at the cars, and worldwide there's 47 million cars produced every year. So this will be somewhere in, not close to the 800 and not close to 45 million, but somewhere in 10,000 units per year by 2030 if you want to scale these operations. So I think it's really important that we scale these operations, benefit the entire society, they be acceptable based on the safety, noise, and performance characteristics. So that's the kind of research we are working on. We're delighted to be collaborating with all partners here, as well as several members from NATCA and FAA Tech Center, as well as FAA headquarters. So we're excited to continue that collaboration. And as I think Will was saying, without collaboration, this will not happen for sure.
Rob, I'm scared to use the word traditional, but is there something from all the research that PK just described that could see benefiting traditional airline operations?
Yeah, absolutely. And if you'll indulge me first, I started 30 years ago in aviation, and after a couple flavors of turboprops, my first jet was a 727. I hold the chart upside down when I was flying southbound to be able to know what's left and right. I still don't know how the controllers can do it without doing that. I watched, my segment, traditional aviation, evolve over time, from, the 727 with, basic instrumentation to, glass cockpits, FMS, datacom, crew alerting systems, all this technology. And of course, the air traffic management side, TBFM, now I think they were talking about infocentric NAS and, the integrated airspace. So we see all these evolutions, and it doesn't only come from, our segment of aviation, it comes from across the board. So I see a lot of the opportunities that PK was talking about, particularly with some of the traffic flow management piece, but also, in terms of the cockpit as well. I'm going to be very careful what I say here. Alpa is here. We talk about autonomous flight, and I am, the soundbite is not Captain Goldman is saying that airlines are going to have autonomous flight. But maybe there are some aspects of that could be used as tools for the pilots to be used in the two crew cockpits as well. So we're very closely collaborating, across the board to see what parts of this we can bring in. Of course, we're all looking for a safer operation, and I see a lot of opportunities there going forward.
John, anything to add there from the FAA perspective and some of these short-term challenges and what you're focused on?
Well, research is really the key, right? So we work closely, PK and ourselves at NASA, right? So all the research that PK talks about, right? Our teams work together to align that work, for us to work with him to realize what parts that he's working on are very important to transition to us, to move us forward in these things. But we have so many different efforts going on, right? Just if you go back to the modeling and simulation that I talked, right? Having the right models for the aircraft is the key. So Joby, we have what we call cooperative research agreements, right? They agree to give us the data and even connect their simulators to ours so that we get full fidelity. We're doing that with multiple operators when we do that, right? We're connected to the NASA simulators, right? We're connected to the AFS simulators in Oklahoma City, where that simulator has TCAS in it. So as we're running these scenarios, we can see if you're getting TCAS interactions on some of these scenarios as you do them, right? You get that full vetting of the scenarios. And that's just on kind of pulling together our near-term stuff. And then we could always go into what are those other enablers like the airports, right? There's research being done on vertiports, right? We need to know the performance, the downwash, outwash from these vehicles to understand how big a pad they need to land on, how they're going to approach these pads, all these different things. So there's tons of research going on. And then we could spend another hour if we transitioned across to the autonomous stuff, which is working. So we have all these threads kind of working in parallel here, getting the near-term implementation done, but then doing that intermediate stage and that longer-term autonomous stuff. And, if we asked Joby for what their definition of the long-term of autonomy was, and I asked Rob for his, we probably have all a little different timing in those things, but it's not as far off as some people would think if they would have picked long-term. It's pretty close in when these operators.
Shorter and shorter.
That's right. Autonomy is not
isn't
very
it?
far off
Yep.
if you're X-Wing, Reliable Robotics, WISC, and Joby, and where they want to go for their long-term business models, right? So we're really working hard in those areas.
And we heard yesterday about leveling up, right? I have to give these guys a plug because they've really leveled up the simulation capabilities to be ready for this. When you go out to our technical center in Atlantic City and you see this, like John was talking about, we're integrated with NASA. When you think of we look at our old air traffic sims, you think of an RPO, someone's going to be on just a regular computer and hit heading, altitude, whatever. No, these are up to, but not including, full motion simulators. Airbus 320, a Boeing 737, and this NASA UAM flyer that has the ability to take the performance data from the different OEMs and fly into our simulator environment. So we'll take PDAR's data, right, real traffic data from the NAS integrated into the simulation environment, and then we can have actual pilots flying these variety of different aircraft into that environment while the controllers are working it, and we can see what those interactions look like. And that level of capability is what's required for us to maintain the gold standard, safety standard of the NAS that everybody expects, right? We have to be able to take it to that next level to be able to move forward. And it really, when you go and see it, it's incredibly impressive, and it gives us the ability to look at what is some of the most challenging things with integration, and that's the off-nominal, right? If everything goes smoothly, well, at least I wouldn't be sitting here. I don't know about the rest of these guys, but we are here to try to solve that off-nominal, and there's not a better place to do that than a safe environment and a simulator where we can do that research, get the data, and build from there.
So I just want to build on that a little bit. So everything that you just described, what have you learned in terms of potential policies and procedures that our controllers will need?
Well, it's a great question. We're still learning that, and Christabelle touched on it a little bit earlier. The big thing that we're all waiting for, kind of the elephant in the room, is the powered lift rule that is expected to roll out in October, and all indications are it's on time. Powered lift rule is what we call an SFAR, or Special Federal Aviation Regulation. So I jokingly say it's the final rule for the final rule, right? Because it's looking at, the expectation of this is to guide us for about a decade. So we can get people on board, get the operations into the NAS, but learn from it and evolve, and then maybe, tailor what will be the ultimate rule to reflect what we've learned and what will, again, maintain that safety standard in the NAS. But literally having that, it's regulation, right? And if anyone's ever read a regulation, it needs interpretation. So we can't wait for the powered lift rule. We can't have the powered lift rule come out and then certify an aircraft the next day. We have to be able to interpret that policy, and then going back to how we started, we have to be able to train the workforce. They're ready and willing to make this stuff happen. Everyone's excited about it, but we have to be able to tell them what air traffic service provisions apply to these new and novel aircraft. And so that's really a biggie is the powered lift rule. Another thing I think you'll see that came out of that FAA reauthorization bill, and Joby, we've talked with them about it before, is there's a strong suggestion from Congress for us, especially in the near term, to utilize letter of agreements to help enable these operations, especially at some of our busier airports. All the controllers in here know, an LOA is only as good as it's written, right, and how well we develop that. But it'd be remiss not to recognize where we are here in Las Vegas. So when you hear about the naysayers saying the NAS can't handle this, the scale, the building up, I'd like to remind everybody that Las Vegas Airport is one of the 10th busiest airports in the United States with legacy air carriers. I'll try that. Is that better than traditional?
I don't know.
With legacy air carriers. And at the same time, they run thousands and thousands. I mean, we're getting 80,000 helicopter ops a year seamlessly. And one of the ways they do that is with a robust letter of agreement that has signatory from multiple operators. So you could have multiple different companies or use cases in here that's highly trained with expectations. The controllers know what's going to happen. The pilots know what's going to happen. And it provides a tremendous amount of scalability.
I want to get to some of the audience questions here, and I think, Christabelle, this one's going to be for you. What will be the hiring and training requirements to become a Joby pilot?
So there's a lot of ongoing work around training, so in collaboration with the FAA around what that training would look like. So what I can share is that flying the Joby aircraft is like flying an aircraft that takes off and lands vertically, but that flies forward like an aircraft. So for now, following the same pilot training that any Part 135 training you can get is the direction. There might be some specificities associated with the aircraft that will basically live on top of it, but that's basically the direction we're taking.
Another question from the audience, and I think this has been one that has been top of mind for many of us, is the business case, right? And PK, you talked about equitable access. The question here is just about cost. How much will it cost to pull it up and get a ride on Joby? So what is the estimated cost, for example, between Wall Street or 34th Street Heliport and JFK?
Well, breaking news, I'm not going to announce any costs. However, I can share that we have a product intelligence team at Joby that is looking at demand patterns, that is looking at existing demand between the Wall Street heliport, the West and East heliports in Manhattan, and JFK and Newark. And so there's precedence. I come from a team that was at Uber, and Uber Elevate the team that actually put together a service, a multimodal service with Uber cars that would pick you up, take you to the GRB heliport, fly you to the heliport on GFK property, and then take you to your terminal. And so we simply basically use our black car model to kind of establish baseline for what the cost will look like. But again, I'm not announcing any cost. Simply there's precedence, and we'll basically adjust accordingly as the demand and the patterns establish themselves.
Good, good. This actually speaks to a little bit of the seamless modes of transportation and what you just described. The question is, will you have to book your Delta flight, Uber, and Joby transportation separately in different apps, or will it be one seamless purchase on the Delta website? Any thoughts on that?
I can start. That sounds like a nightmare if you actually have to use 3 different apps. No, the intention here is to provide a seamless service. So literally, you pull up your app, you enter your origin and your destination. In the back end, in our system, an engineer, I'm talking a little software here, but we're building this system that basically takes your origin and your destination and will create a multimodal trip. So what do I mean? Typically, those multimodal trips means 3 legs. The first one will be, okay, maybe your car picks you up and then takes you to a port where the Joby will operate in and out. And then, well, you'll fly your second leg in one of our aircraft. And then the last leg will be maybe walking, or maybe simply another car to take you to your final destination. That seamless integration will do it for you. So when comes the time of your trip, say, oh, my driver is coming, and then I'll meet that person, just like your Uber is picking you up these days. And then your app basically will automatically change and give you the information that you need as your trip progresses until you reach your final destination. So not 3 apps, 1. Now, there's another piece of the puzzle here is about the Delta side of things. And it's not like there is any official solution just yet, but we are in collaboration to determine the best way to basically bring up a Joby when you're on a Delta flight and vice versa. And so that will, again, combine the 2 efforts into one, into the Delta world or in the Joby world, to ensure that the Delta passengers can connect between Joby and Delta in a seamless way.
As long as I only have to do my check luggage baggage fee once, that would be good. PK, you want to
I was just going to ask, who will give me frequent flyer miles? That's
Yeah.
what I care.
Where do you want to use them?
Excellent. Well, with that, I'm going to just give each of you a chance to share with the audience anything from your perspective that you wanted to add as we're thinking about navigating this future together. So PK, I'm going to start with you. Anything?
Yeah, no, certainly we are very eager to work with you all and FAA to make sure that we can seamlessly grow the capacity of air transportation system without interfering with each other, right? From drones, advanced air mobility aircraft, fixed wing, as well as rotary wing. Then, of course, helicopters, general aviation, we got conventional air transportation, crewed aircraft, uncrewed aircraft in the future, and high altitude operations. So our goal is to make sure that we can seamlessly grow that air transportation system and look at a broader architecture that's necessary, working very tightly with FAA. The broader architecture and functions needed on the aircraft side, functions needed on air traffic management side, the roles of humans, information that's needed, and then infrastructure that's needed to support entire operational paradigm here as we move towards what we call Sky for All vision. So there's a lot of research. Advanced air mobility offers the stepping stone towards that. We started that moment with unmanned aircraft system, traffic management, UTM, a little bit, it's 400 feet and below, but we are learning a lot from that experience and figuring out how do we actually make sure that operators have the information that they need to maintain their operations in a safe manner while understanding the role of the ANSPs, at the broader stage, and what the basically constraints they have, and how do we actually manage that. It's, at the end of the day, it's demand capacity constraint management. And then comes other new types of operators that are, commercial space and such. So it's really exciting future for all of us to scale these operations with the density, diversity, and the complexity that we are postulating, now and future. So we are looking forward to conducting simulations, the ConOps studies that we are working with FAA, with industry. We are working on a lot of these applications that will enable them to get their efficiencies for every flight and the network, and then working with new entrants like Joby and others to ensure that they can seamlessly fit into this without overloading the ATM. So we are really excited about that, and always open to collaboration and ideas and exchanges with you all.
Thank you. John?
It's a real exciting time. I mean, this is kind of a pivot point, right? It's the next big thing that's coming. This early stuff is kind of what we've done for years, from the early integration, but the next pivots to the autonomous operations and the high flow. If you look at the amount of money DoD has put into autonomy and where DoD is right now, and we all know those big technological pushes, DoD's money normally gets you going. Where did GPS come from? Where did a lot of other things come from? DoD's that incubator and really cooks and jumps out. And there's huge amounts of money going into autonomy. And it'll push our thoughts and what we have to do. So it's going to be really crucial to keep doing all this research that we're doing, to really move forward, to collaborate with all the stakeholders, getting that input from all the different stakeholders, having involvement for controllers, stuff as we go there. But that push to autonomy, and as I said at the beginning, it's probably not as far off as a lot of you would think if I just said pick what long-term is. If you just look at what DoD is, where the different manufacturers are, the X-Wings, the reliable robotics, what Joby is looking at, what WISC is looking at. There's some exciting stuff out there, and it will challenge us to be flexible and nimble in how we're going to operate in the future. So.
Thank you. Rob?
So pilots are a lot like controllers. I'd say, you hear about change and we find out all the reasons why it's not going to work. Then we start doing it and we say, that's not too bad. And then, years later we say, we can't go back any other way. So I think that's where we are right now. We're at the very beginning, of that. I applaud, the FAA, NATCA, our industry partners with Joby and NASA and everyone else, and of course the theme of this conference for the past several days is always focusing on safety, always making sure whatever we introduce into the NAS is going to be safe, and we're going to have backup systems and all that, and just all the legwork that's going into this, the next chapter in aviation. So it's exciting to be part of it. I think we're doing it the right way, crawl, walk, run. And I think, ultimately we're going to be able to serve our communities, our customers, the public in a safe manner that provides for people going forward.
Well said. Thank you.
When you look at it over the history, the NAS has continuously evolved, right? Air traffic control started out with the flag. And when the flag didn't work anymore, we got radios. And when the radios weren't quite enough, we got radar. And now we have ADS-B. And you see this continuous evolution, and I think we'll see that with this as well. The near term, we're ready. We just need a little help along the way. But as the operations continue to scale, we'll scale with them. It'll evolve with the people that have continuously kept the NAS the safest in the world, safest and most efficient in the world. So I think we'll see that going forward. I think what's most important and what really has determined our success thus far and will continue to do so are the relationships that we have to move that forward. The trust that we have to have amongst us between our agency partners, NASA as the researcher, the airlines, the new AAM industry. You don't develop that overnight. We've spent a lot of times in session, at the bars afterwards, hammering through things, figuring it out, and coming up with these solutions. And really being able to trust each other to move this forward, I think, has been super important, and it's going to carry us.
A few words. Well, at Joby, we are really focused on making this air taxi service to life and bringing it to life. We've been making progress. We're building the aircraft, but we're also planning our operations. And we know there's so much we can do by ourselves. And so we're really happy to rely on this partnership and this collaboration and this simulation activities, the one that we did last year with NASA, for example, and this year now with the FAA. And we know that this is the only way, and that we are looking up to the regulator to basically provide the guidance for us to start operating. And I'll just say again, we want to seamlessly integrate in the national airspace. We don't want to increase the ATC workload. We want to bring the people where they want to go because it truly matters, and it's really something that has been core to our values since the company has existed. And so we really appreciate this partnership, and our pilot will follow what you tell them to do.
Wonderful. Well, thank you. Thank you all. I really want to thank the audience. I want to thank NATCA for letting us have this conversation, and then especially thank the panel members. I am certainly excited for what the future brings. So thank you all very much.